So this is me, Deepak at PuppetLabs.com. If you have any further questions or want to sign me up for awesome email forwards about discount shoes or cat pictures, that's me on Twitter. How many people are actually already using PuppetDB? All right, that's good. It's okay. It's okay. We need to talk. We need to talk about data. You wouldn't believe how long I spent trying to find that, by the way. So it turns out that Puppet actually generates a pretty large and useful abundance of information. So you've got your agent, you've got your master. An agent starts up, collects some facts about itself. So what are those? What do those look like? So facts are basically a bunch of key value pairs about all kinds of interesting metadata about the system that you're actually running on. Everything from how many processors do you have, am I virtual, how much RAM, et cetera, et cetera. So that's a lot of very interesting, thoughtful information that the agent sends to the master. The master takes that and turns it into a catalog and just throws it away, because that sounds smart. The master generates a catalog for you. So what's a catalog? A catalog is something that takes your Puppet source code. I have a file, temp foo, this is the content of that file, this is a test. That's going to get turned into, this is a YAML representation. No one should use YAML for anything, by the way, because it's basically the worst. Except for slides. Slides is totally legit. So there's a lot of information about this resource. You have what file it's in, what line number it is, any parameters to it, all the tags, all kinds of interesting stuff, as well as things like relationships that resource has to other resources. Taken in summation, this is called the graph. So this is an example of a graph from an actual Puppet Enterprise installation. I did a dump of the resource graph for installing Puppet Enterprise on a node. That's a small snapshot of it. We can zoom out. It's an actual bigger graph. We can zoom out. That's actually a pretty gigantic graph. So there's a lot of useful information in there, right? I mean, it's every single thing that Puppet is managing on every single one of your systems, how they relate to each other in every possible way, all available. So of course, what the Puppet master does is it doesn't store a copy of it itself, and it happily hands that back to the agent to run to configure the system, and then the agent just trashes it. Of course, again, very thoughtful. Agent generates a report of what happened. So what's in a report? A report, again, YAML. A report tells you what actually happened. The catalog contains what you want the universe to look like. I want this file to have this content. That's the way things should be. The report is what dashes all of your hopes and dreams, and it tells you how the world actually looks. And it's, hopefully most of the time it tells you that it's actually configured the system to look the way that you want it to look, but in case it didn't, it at least tells you what went wrong. So the agent will take that report, send it over to the master, which maybe we'll toss it onto disk, but basically I consider if you want to look through reports, if you have to crack open grep and go through a directory like that, you may as well just be throwing it away. That's not structured data. Like, what century is this? Come on, man. We can do better than that. So what PuppetDB brings to the table is kind of a slight variation on this. An agent generates some facts. Facts go to the master. Facts get sent to PuppetDB, which does not throw them away. It's such a simple idea. Why didn't we think about this before? The master generates a catalog. It can spool off a copy to PuppetDB for storage at the same time that it hands that copy back to the agent, which is also great. Notice, again, what is not being thrown away. Very, very handy. Agent generates a report. The report comes all the way back to the master. Master needs to figure out what to do with it. The master can send it to PuppetDB, where it is kept. OK, so that's a really brief introduction to where all the data goes. It goes into the big green cylinder, obviously. Not included with every installation of PuppetDB. So this is not a new idea. We've had this before in Puppet for any of you that have used store configs in the olden days. I like to call them slow configs or shitty configs. It's based on a library in Ruby called Active Record. And basically what we try to do using that system is exactly the same kind of setup. We try to capture as much of this data as we actually can in a structured way in a database so people can actually query it and do interesting things. It turns out, though, that this is actually, this didn't work very well. And it's a little hard to, it seems great at first, right? Like I have some catalogs, I'm sending some catalogs over, everything's great. How are you guys doing? Everything all right? You know, your Puppet deployments are going okay? And then all of a sudden it's like, ah, all my shit is on fire and everything is ruined because it's like the most inefficient stuff that we ever had in the universe. But it's okay because, you know, I mean, the worst possible case scenario is that your database is kind of hosed, and that's totally fine. But, you know, you at least retain the ability to configure all of, oh my God, this is all ruined. It's all ruined. Because, of course, if you take down one of the processes that's trying to store all of your stuff, then that process can no longer process any new catalogs, which is a bit unfortunate. But at least you have all of your agents. Surely nothing possible. Oh, man. This is bad times. Darkness washed across the land. You know, in addition to it just routinely going up in a ball of fire, which is always hilarious, you know, this isn't really a way to programmably get access to any of this information because, you know, ultimately this is a SQL database. Unless you're comfortable writing a bunch of SQL statements, you know, you're really not going to get much interesting stuff out of it. You know, so you can't really. There are a lot of questions people want to ask, right? Like I got all these resource graphs for everything. Maybe I just want to know which of my boxes are, you know, running Nginx. You know, how many servers are running a vulnerable version of Rails? Spoiler alert, every version is vulnerable. What are the IP addresses of my web servers? You know, which users have sudo access? You know, these are all perfectly reasonable questions that anyone would want to pose to a kind of a data warehouse of all of their Puppety knowledge, right? So, you know, what the old system used to do is it would basically think about it. It's like, okay, that's pretty good. Maybe, I don't know, I'll wait a little bit longer, think about it a little more. I don't know, this takes a really long time. It's like, that's unfortunate. That's literally what would happen. I would get like look of disapproval. Son, I am disappointed. You don't, but I mean, it would, it's so slow. All right, so I'm not gonna shit on Active Record anymore. I'll let it do that by itself. Okay, so now for something completely different. The new world. You know, so I wanna ask PuppetDB a question, like, I need to know all the machines that have Nginx running. I could just do a query, /resources/service Nginx. You know, and it happily gives that back to me. And you have a smiley face. That's how you know it's better. And you could do this for, you know, a whole bunch of different queries that you'd like to do. I need to find, you know, all the versions of Rails that are actually running somewhere. You know, I can get that. I happily get my resources back. And again, smiles all around. It's smile-oriented development, I think, is what I was really going for. I want to find all the record, you know, all the parameters for setting up my own user account across my entire infrastructure, or actually just on the node foo.com. You know, so nodes, foo.com, resources, user, me. That should be really, really straightforward, right? So, briefly, let me try and actually show you guys PuppetDB actually running. Let me try to mirror. Whoa, all right. You don't really need to read it, but trust me, it's actually doing stuff. Okay, so PuppetDB is a daemon, so unfortunately there's not a lot of like, if you actually care about what it looks like when it's running, I've probably done something really, really wrong, right? I mean, you don't want to know. I don't want you to know. I mean, I want you to know, but not that badly. Okay, so PuppetDB candidly includes within its own source tree a benchmark tool. So what I'm going to do is I'm going to run benchmark against my PuppetDB installation. I'm going to be handing it a bunch of catalogs that I actually got from a snapshot from our operations team. I'm going to simulate 1,800 nodes. This is running on my laptop, by the way. And 1% of the time, I'm going to randomize resources. So we'll let that spin up in a second. Buffering. It's got to think about it, you know. All right, so it's submitting catalogs, and I'm getting information there. All right, so the reason why this is happening at this cadence is if you have a 30-minute run interval, 1,800 nodes. If you do math, this is America, but trust me, if you do math, that turns out to about one catalog every second. So what I could do is bring up the dashboard. And you can actually see it, running and doing things. So this particular database I have, there's about 700,000 nodes in it. I've got some pretty high duplication measures that I'll actually talk about a little bit. There's an internal queue. You can see the health of it. There's a bunch of other interesting metrics on here. This is all just to say that it's instrumented out of the ass, and it's actually fast enough to handle 1,800 nodes worth of catalogs on this bitterly antiquated MacBook Pro Retina. It's pretty sweet, actually. You should get them. So anyway, that's what it does. I don't need to belabor that point, so I'm going to kill this. Then go back to here. Resume. OK. So in a nutshell, what that benchmark tool is doing is it's taking all these catalogs from our operations team. It's simulating 1,800 nodes worth of data, firing them off at PuppetDB, and then what you were seeing, if you recall, the numbers on that dashboard are like a couple of hundred milliseconds to actually store that entire catalog. That's the entire graph, every single resource, every single parameter, every single relationship, all the edges, all the facts, reports, everything that all gets stored in a couple of hundred milliseconds. In order to make that happen, and for reference, I mean, the old store configs implementation would happily work up to about maybe 50 nodes, maybe 100 nodes, and then you'd be ruined. So we had to build something that was pretty different, I think, in order to make this work. And when we did a couple of, at least internal to Puppet Labs engineering, we did a couple of what I would say are some fairly unconventional things relative to how the rest of Puppet or Puppet Labs software is constructed. Number one is we baked in asynchronous operation kind of into the core of how this stuff works. Really, PuppetDB, what it's supposed to do, it's supposed to provide two basic features. Number one is it has to store stuff. Number two is it has to let you query it. It turns out that there's an architectural pattern within software called CQRS, which kind of describes this pattern pretty nicely. It's called command query responsibility separation. But in a nutshell, what that means is you want to use a different model to update information than the model you use to read your information. So effectively, that means that you can think of your application as two separate pipelines. There's like a pipeline for how you want to make modifications to all of your data. And there's a completely separate pipeline for how you want to actually consume that information, right? So they're going to be different. This is kind of most software is not designed in this way. So what that lets us do is our write pipeline. We made asynchronous from the beginning. It's heavily parallelized. It uses an internal MQ that you guys never have to actually maintain because it's just embedded inside of the software itself. And we do things like automatic retry. So when I say write pipeline, what I mean is you're not doing an HTTP post. When I first did this, I think it was somewhat controversial because people were like, oh, well, if I want to store a catalog, why can't I just do HTTP post/catalogs, and then here's my 18 megabytes worth of catalog, and then you just wait, and then you hand me a 200 OK when it's been stored. I'm like, that's fantastic until you run out of available threads, or you run out of available cores, or any of a number of things that pose real scalability limits on what you can do. So this is what a command looks like. All the write requests to PuppetDB are formulated like this. There's a command name, like I want to replace the catalog. Every command has a version. There's a documented wire format for this protocol, and it has a payload. And if you want to know what the payload looks like, you can go to docs.puppetlabs.com. Nick Fagerlund did a really great job of documenting all of this stuff. So if you wanted to have your own system that pumps data into PuppetDB, that's completely open, it's completely supported, versioned, backwards compatible, all that good stuff. Internally, the pipeline looks something like this. Commands come in. They go into this embedded message queue that we have. It's actually ActiveMQ, but like I said, you never have to actually mess with it. It's completely internal. We take the command, we parse it, slice and dice it, do some validation, some transformation, and then finally we process it. So if we get a replace catalog command, the processing step is actually going to translate that big object into database insert statements. It'll do deduplication, all kinds of other interesting stuff. What's novel about this is what happens if I want to do an HTTP post, here are all my catalogs, and I'm waiting for my 200 OK, but say my database is down? Like, what do? If you were using software, I mean, most of the software you guys probably use, it's just going to throw you an error, which sucks. That sucks. Why do people do that? Instead, what we can do is because we already have the baked-in assumption that writes are going to be asynchronous, we can just queue up that same catalog to retry later when the database is back up again. So we can toss it back into the MQ. all my magic tricks come from like how SMTP worked in like the late 80s. So if you can't relay a message to someone and it doesn't work, like what does your mail server do? Does it just drop your message on the floor? Does it hand you back a bounce? No, I mean, it'll try again with exponential backoff. That is literally what we do. We'll queue it again for 1 second later, 2 seconds, 4 seconds, 8 seconds, 2 to the whatever, all the way out to like 9 hours or something. Stuff can bounce around. And then finally, at the end, if none of that works, we have this directory on disk called the dead letter office where we spool all the data to. And it's actually a bit-for-bit copy of what you sent us over the wire, which is really nice for me as a developer, because that way, if you guys in the field are using PuppetDB and you run into problems or errors, you can actually take the file from that directory, send it to me, and I could replay it through my own PuppetDB system and reproduce your error exactly, because there's no other mysterious information at play, which is awesome. Why don't people do that? And you need to, basically, you need to expect failure because it's going to happen. You know, it's a complicated system. I'm getting new data, I have to dump it into a database. Like, there's a lot of stuff involved there. You know, if even at any point in time, you know, things go sour, you know, you need to be able to deal with it. Failures like, I don't know, if a database explodes. In fact, let me see if I can explode my database. Okay, shut that down. Please work. It'll work. It'll work. It's a sound architectural principle. You know, of course it's going to work. So what you should see in theory is this command queue actually going up. Yep, there you go. Yeah, of course, you're not getting information about how many nodes or resources you have because that has to hit the database in order to figure it out. But that's the key. So notice that Benchmark is still submitting all the catalogs that it can, about 1 every second. But you know, we're happily queuing things up. So now, in theory, so wait for it, wait for it. All right, so stuff starts to go down. That is how software should work. So take your database down for maintenance. It's going to be OK. Everything in Puppet should work that way, really. Oh, also, did you notice I'm actually using more than 1 core? Just thought I would throw that out there. Things Ruby can't do. Is it too soon? It's too soon. Too soon. Other unconventional thing we did relative to all other Puppet Lab software is we used a new language runtime. Notice, things Ruby can't do. Stuff I know I needed. We needed stuff that was, we needed a runtime that was fast. We needed one that was free, because it has to be installable everywhere. It has to be portable, so it can't exist on, you know, it has to work on Windows. It has to work on, you know, all the platforms that we ever hope to support or have PuppetDB run on. Has to be multi-core, because again, it's 2013, and my phone has more than 1 core. Try running Ruby on that. It's sad. A Ruby app can't max out my phone. Or like a Lego Mindstorms kit. Come on, man. What century is this? Who's the president? Ronald Reagan, the actor? And it needs to be something popular, like something with an actual ecosystem whose libraries I could reuse. It turns out that the most boring of all possible choices, the JVM, actually has all of these things in spades. Haters gonna hate. Yeah, but fuck those guys. Actually, it turns out that there were very, very, very few people that complained. I could actually count them probably on 1 hand, I think, and then punch them with it. But no one. It turns out no one really cares. I mean, ultimately, at the end of the day, no one cares what. I mean, Hacker News, armchair architecture aside, nobody gives 2 shits about how your stuff is actually built. You know, as a user, what I want is I want my stuff to work. You know, if it's easy to install, it's efficient, and it actually works. It could be a bunch of PHP scripts cobbled together. It could be a Visual Basic app. Like, I don't know that I really care. Maybe I would care about VB, but you know, but it doesn't really matter. So one of the really nice things immediately that we got from using a new runtime is that there are tons and tons of high-quality libraries that are available. For example, I can embed an MQ inside of PuppetDB. ActiveMQ is like a 700 kilobyte jar file, and I can throw it in there and then start using it as a library. You never need to know. We include our own web server. I started up PuppetDB. Notice what I did not have to do was install Apache, install Passenger, tune a bunch of random crap that nobody cares about. Instead, I can just do like, here's the, you know, java-jar PuppetDB. And then it starts. It automatically figures out how many cores I have. It automatically allocates threads. It has a web server built in. It has an MQ built in. We even include an embedded database if you're like so morally bankrupt you don't want to set up Postgres with like the 2 commands that it takes to do it. You could set it up, and that actually works totally fine. It turns out about like 30% of users out there run with the embedded database, despite every talk I give telling them, please don't do that. Don't do that. It's pretty fast, actually. That's because it loads up literally all of your data into RAM at once. Go figure. And there's a ton of debugging and profiling tools available. This is something that was controversial at first and now seems really stupid that we even debated this internally. For example, I was helping a customer last week. They were having some issues where PuppetDB was, it would start and then it would crash and they didn't know why. And I was like, well, are you getting an out-of-memory error? And they were like, oh, yeah, we are. Can you fix that? And I'm like, yes, I can. If you look in this directory, there is a heap snapshot because we set it up with the unit scripts to automatically dump the heap whenever we have an out-of-memory error. You can send that to us, and I could load it up in a profiler and triangulate exactly what line of code that's leaking memory, and I could fix it. And in fact, I'll talk about the secret alien technology we use. I could actually, if they have a port open, I could telnet into their PuppetDB instance. They have to do it. They have network access, and you could actually hot patch the server live to include a code fix without taking it down. These are things you can do with a real runtime. We can ship in UBERJAR in Java parlance. That's basically you take all your dependencies and you essentially, it's a structured way of vendoring everything, which sounds terrifying, but what that means is I can hand anybody like a 12 or 15, I think it's like 12 or 13 megabyte file, and that is PuppetDB. That's literally all you need. You don't need any other dependencies except the JDK itself, which is usually an apt getaway. And it just makes deployment really, really simple, and there are no moving pieces. Again, you don't need to install a web server or any of that other banana stuff in order to get this stuff working. And it's plenty fast. Like I said, it's a couple of 100 milliseconds to actually store a catalog, but think about what that means, right? And we've done performance statistics because in order to get the data to PuppetDB, we have Ruby code that plugs into the Puppet master that takes the catalog, takes your facts, serializes it to the wire, and sends it over. That usually takes, on the Ruby side, I'll put it this way. It takes more time on the Ruby side just to get a catalog and serialize it to JSON over the network. It takes more time to do that than it does for PuppetDB to wake up an embedded web server thread, spool all that stuff into memory, parse the command, do data transformation, validation, put it onto the MQ, wait for a transaction acknowledgement that it's been accepted by the MQ, wait for a completely different thread to actually pop that off the front of the queue, again, do data sanitizing and validation, translate that into a bunch of SQL statements, open a transaction to the database, serialize it, transaction commit to the MQ, return an acknowledgement to the user. That happens in almost about 60% of the time it takes for the Ruby code to do that one small task. The PuppetDB code has already persisted this to disk. So what the hell, man? And like I said, ultimately, nobody cares what runtime we use. They just want our stuff to work, which makes sense. Other controversial thing we did. The query language is basically an abstract syntax tree, which really freaked a lot of people out, I think, when I first did it. This is one of the things that took the longest time, I think, for me to convince people that this was not a terrible idea. Queries are expressed in their own kind of miniature language, right? Like, I know I didn't want to have people sending raw SQL statements over the wire. SQL injection as a service. Like, what could go wrong? I guess WordPress already exists, so I don't need to. Too soon. So we basically came up with a domain-specific kind of language. And queries look weird and like this. Like, if I want to find a user where the title is me, I formulate it like that. For any of the computer scientists out there, I mean, this is an abstract syntax tree. It's like if you parse a language or you parse a grammar, that's effectively the data structure that you get. If I want to find all the Debian systems that have an uptime of more than 10,000 seconds, I could do it like that. We have SubQuery Support. This is an example of I want to select all the resources that have the Apache class. And then for each of those records I get back, I want to yank out the cert name or the node, what node they're on. And then I want to find all the nodes where I want to get the IP address fact for each of those nodes that have Apache on them. That's a really simple thing. I just want all the IP addresses of all the nodes that have the Apache class applied to them, right? Because it's an abstract syntax tree, we could potentially start doing things like optimization. Someone could submit a query that looks like this, And I could translate that into, say, like a more efficient SQL statement, right? Like an in operation, where instead of having a bunch of OR clauses chained together, I could actually collapse that part of the tree and do something more interesting. So in a nutshell, we walk that tree, compiling it to the most efficient SQL that we can possibly come up with. So we don't use any object relational mappers or anything like that. People are, you know, you look at that and you're like, oh, really? I got to do that? That's ridiculous. There really is a benefit to this. And the benefit is twofold. Number one is I was not at all confident in my ability to come up with a query syntax that I think everybody would like. Because that's hard to do. I mean, it's hard. Especially one that needs to be able to support all the features that we care about. You know, it needs to be able to support subqueries. It needs to be able to correlate stuff between resources, facts, nodes, regular expression, equality, greater than, less. I mean, there's a lot of stuff that we would need to do, and if I just got an opaque string over the wire, like that's just really, really unfortunate. What I was confident of is that if you write a library and you want to spit out queries or generate queries to integrate with someone else's stuff, you want an interface like this. Anybody who's ever written a script that smashes together like strings in order to produce like a SQL statement, like A, I'm sorry, and B, like I'm doubly sorry. Because that's really unfortunate. What's way easier to do is actually assemble this in your code using code-like constructs. And that's exactly what a syntax tree lets you do. So if people that are smarter than me, like Eric from Spotify, who's also giving a talk, it may have already happened. I apologize, Eric. You know, he wrote a query language that looks like this. You know, it's much more natural language, much more friendly for a user, and it compiles. You should look at the code that actually implements serializing this to a PuppetDB query, and it's really, really tiny because you don't have to do any crazy string concatenation madness in order to make that actually work. Having it be based on the syntax tree lets us manipulate it in code. So, you know, in PuppetDB 1.2, I think we rolled out changes to our API so that you no longer have to, by default, will only search nodes that are currently active, that are actively getting catalogs and actively seeing facts. Now, in the normal world, what you'd have to do is you'd have to take that string that someone was passing in as a query, parse it into that tree, and then you'd manipulate the tree to add another clause on top of it that says like, and the node is active, and then the rest of the shit that you asked for. But we can do that all in code in just a couple of lines, and that's allowed us to evolve that query API much more rapidly than we were able to do before. Like I said, because this turns out to be really easy to generate queries, that means it's kind of, it's wonderful for integrators, I think. And you end up with people writing, you know, really interesting dashboards and stuff like that that talk to our stuff. This is from Danny on the Puppet Free Node channel. And he made Puppet Board, which is really cool. Actually, the other day, he sat down with myself and Nick Lewis, and we hacked together some more pages to display real-time metrics out of PuppetDB, so it's pretty nice. The Puppet Enterprise Event Inspector that you saw during the keynote this morning is actually based on those exact same APIs and the exact same interfaces. We don't cheat. PuppetDB exposes these APIs, they're versioned, they're documented, and if our commercial products need something out of it, then we know we need to evolve that API to make it work, so everybody kind of benefits. But everything that you see these tools do, you could do from the command line, from a script, you could use it to integrate with other tools, whatever it is that you want. There's a bunch of so really, okay, the proof is in the pudding, right? Like my conjecture is that having these APIs designed the way they are is conducive to people creating more interesting and novel integrations with our stuff. CERN produced Foreman integration. There are 2 additional web UI projects in varying states of complexity and completeness. The bottom one I know uses Play Framework Scala. There are a handful of different Ruby integration libraries. Eric from Spotify wrote probably the most popular one, which is PuppetDB Query, which actually provides in language, you could use in your Puppet DSL code, you can just write queries against PuppetDB, to like rapidly spit, get me all the services everywhere. And I'm going to take that, throw it into a template, and then spit out Nagios checks in like 100 milliseconds. Instead of taking like 150 seconds or whatever the default Nagios types take. He actually wrote a library that, for the Ruby programmers out there that use a library called Data Mapper, which is kind of an object relational mapper for Ruby. He just wrote a backend for that talks directly to PuppetDB. So in your Ruby code, you can leverage that stuff exactly like you would leverage anything else. Oh yeah, oh that's right. He wrote a Hira backend, so you can do Hira lookups, and that data is actually yanked straight out of PuppetDB, which is awesome. Pinar wrote another library that has his own query language that he uses for mcollective integration. So on the mcollective command line, you could actually talk to PuppetDB and do discovery. So if you have 1,000 hosts or 10,000 hosts, and you want to say, I need to tell all of my Debian machines that are running Apache to restart Apache. Normally, what you have to do in mcollective is you do like a discovery that's going to send a ping out to everybody, and you have to wait for that to propagate over the network and you get your responses back. But you don't need to do that because all that data is already in PuppetDB, and that takes an operation that would take a couple of seconds, and it collapses it to literally tens of milliseconds, which is awesome. There are at least 3 different Python bindings. The one that's used in PuppetBoard is actually the one on the top. It's pretty good. I highly recommend it. There are definitely some other ones and some ancillary tools like grep programs that are also written as well. There are bindings for Java, for Go, for Scala, for someone wrote a gist that has some CoffeeScript code that talks to it. There's a Node.js implementation of some of the protocol side of things that we've got. It's crazy. There's mcollective discovery plugin that you could use today. There are 2 different orchestration plugins for Rundeck. There is Dan Bodie's OpenStack libraries leverages talking to PuppetDB in order to do orchestration between master nodes, slave nodes, things like that. People, if you look on GitHub and do a search for like their Vagrant setups to set up a Puppet environment, they all include PuppetDB now, or they all automate it using some libraries. There's even a dude who has as the back end of his Power DNS setup, he actually talks to PuppetDB to dynamically figure out exactly where, basically to determine routes, which I thought was crazy, but awesome at the same time. I was like, why wouldn't you do that? Like, that's pretty awesome. The other controversial thing, which shouldn't be controversial, is that we chose to use boring technology when everyone else is not using boring technology. In particular, we opted to have a relational database as the back end. You can either have an embedded one or we support Postgres. Because it turns out, if you need to do ad hoc queries, which is what people want to do, infrastructure is data, right? Infrastructure is code, then infrastructure is data, then you want to actually be able to query that data to do interesting things. So if you want to do that, it turns out databases are actually pretty good. I love this comic. This guy's like, so how do I query the database? It's not a database, it's a key value store. Oh, it's not a database, how do I create it? Well, you just write a distributed MapReduce function at Erlang. He goes, did you just tell me to go fuck myself? I believe I did, Bob. Yeah, but imagine where I tell a user, I'm like, yeah, well, you can search all your catalogs and everything, and it's going to be great. Oh, but by the way, you have to set up like a 28-node Cassandra cluster in order to work. They're like, you just tell me to go fuck myself. Depends if you're a commercial customer or not, I guess. We also use a lot of weird alien technology. In particular, even though it runs on a JVM, we didn't write it in Java. We actually wrote it in a functional programming language called Clojure, which I would highly recommend you look at. There are a couple of novel properties to it. It's a functional language, so it takes very seriously everything in the language is immutable. You don't have variables as you would traditionally think of. You have constants for stuff. And that basically means any object that I'm manipulating in the language at any point in time, I could hand to literally as many other threads that I want, and I don't have to do any locking. So you kind of have to wrap your brain around it in order to write your code that way. But we have, among every single other Puppet Labs project, we have literally the lowest incoming defect rate. There have been 0 bugs related to deadlocks, 0 bugs relating to NVM state management. So it's worked out pretty well. And of course, I understand you could write any software and anything else. This guy did a perfectly adequate job of reproducing Starry Night on an Etch-a-Sketch. I just wouldn't do it. I wouldn't do it. So across all the thousands of deployments that we have, there are hundreds of threads that we have going on per installation. And yeah, we've had no deadlocks, no bugs involving any mutable state. And because we ship our own code that plugs into the Puppet Master that's written in Ruby, the Terminus code, if you look in Redmine, that actually has about 10x the defect rate of the stuff that we're doing on the server. And the entire PuppetDB source tree, if you exclude all the test cases, is about 7,000 lines of code. For reference, if you look in the Puppet source tree, type.rb and parser.rb added together are almost 7,000 lines of code. I'm just saying. I had a lot of conjectures about performance in some of the optimizations that I wanted to do. I had a theory that a resource often exists across multiple hosts. My user account probably doesn't exist on one system. It probably exists on a bunch of systems. So we implemented a feature where we'd only store that resource once. Because if it's the same resource across 1,000 nodes, why would I store it 1,000 times? That's 990 times stupid. And it turned, and that was a useful assumption, I think. We had an additional theory that for a given host, we'll often receive the same catalog for that host again and again and again. Because if you have a web server and Puppet runs every 30 minutes, are you really pushing out a change to that web server's config every 30 minutes? Like, probably not. You're probably only pushing it out relatively infrequently. So if I get the same catalog every time, why would I store the whole thing again? I should take a fast path and not store it at all. Dedupe. So we do single instancing of catalog storage. This was theoretical, right, at the beginning, because we didn't know if that was actually the case. And it turns out in the field that we see resource and catalog duplication rates above 85%, which basically means that we basically do no work in PuppetDB about 85% of the time, which is good. So I think that proves out the theory. And what's nice is you can load up the PuppetDB dashboard, look at these statistics, and you should be able to get a good measure of roughly how volatile your environment is. Like if your resource duplication is really, really low, that means you have a lot of resources that only exist on one system. So it's kind of like your snowflake quotient, right? And you don't want that to be particularly high. If your catalog dedupe rate is really low, then similarly, that means that you're pushing out a lot of changes with regularity. It's really, really volatile. And maybe that's OK. Maybe you're in the middle of an application deployment or something like that. But if you're not, at steady state, things should be pretty good. And ultimately, I think what this means is that monitoring and instrumentation is a really, really big deal. I mean, if you present users information like this, they use it. I mean, everybody loves numbers. Everybody loves analytics. Everybody loves at least consuming monitoring, maybe not setting it up or actually using it. But numbers are really, really powerful. Being on a JVM runtime means that we can get all kinds of information about the way that PuppetDB is operating and expose that to the universe. Like this dashboard itself, it's getting all, kind of wish I had a higher res version. Well, when you install PuppetDB, which I know all of you will, you can bring this up yourself. And send me your screenshots, because I collect them. I'm going to make a quilt or something. But all of this stuff actually, all these data points are going over HTTP to PuppetDB. And anything you see displayed here, you can get via command line or plug it into Nagios. And in fact, people have. Jason Hancock, who's in the front row, wrote Nagios PuppetDB, which is awesome. There's an external implementation of Naginator, so instead of using the built-in Puppet Nagios types, you can actually talk to PuppetDB directly to find all of your hosts, resources, whatever, services, and spit out checks. 2 different implementations of union bindings, collect D. I mean, it just really turns out that people appreciate all the details that I think we took care of when, when we built this stuff. In particular, so this is a time lapse of when we released PuppetDB 1.0. I changed the color whenever we release a new version. And you can kind of see it spread over time. Last year, I gave people a lot of shit because we had every continent covered except for Africa. And lo and behold, now we have Africa. So thank you, whoever did that. The center of the world, right underneath Africa? I don't know. Oh, that must have been when we released 1.2, I think, or maybe 1.3. And then you'll see more stuff kind of come in. Anyway, hopefully, while you're staring at this, and these aren't actually downloads. These are actual deployments, because if you bring up the PuppetDB dashboard, we can tell you if there's a new version available. So we use that information to basically figure out what versions are deployed in the field, which helps me as a developer really make the software better. Sorry, you can see the browser slow down because there's so many SVG elements going on everywhere. OK, so that's a lot of stuff. I don't know what's going on down here. Either that's, I don't know, deployment in Rapture or something, perhaps. So there are literally thousands of production deployments, that and it's anything from small shops to just have a couple of dozen hosts to the largest installation I know about is in the tens of thousands of nodes. With the database cluster, multiple PuppetDB daemons. People run standalone. People run with a clustered database or multiple daemons working together in concert behind a load balancer. There's approximately a new deployment of PuppetDB every 15 minutes. So by the time this talk is done, 3 new people will have installed it and actually have it running. So since the last time I actually spoke to you guys about this, which was a year ago, there have been a number of changes which I can blast through pretty quickly because I don't want to just stand up here and be like a human changelog, because it turns out that there are robotic changelogs that are much more effective. Biggest one is that this is available in Puppet Enterprise 3. It's on by default. It's fully supported. So if you run into any problems, you can actually talk to me, which may be great or it may suck depending on how much you like me. Give me a chance though, cool dude. You know, like, it's cool software, cool languages. Is it the cardigan? Is that, all right. Most importantly, I mean, PuppetDB in Puppet Enterprise 3X is going to be the basis for all the upcoming reporting and analytics features that we're going to be putting in. A lot of changes performance-wise since the 1.0 release a year ago. Storage is approximately 20% faster. We made a lot of improvements to how we're doing caching internally. Again, one of the nice things with the runtime that actually has threads is I can cache information that one thread needs and another thread can actually access it. Crazy town. We also did some database optimizations, getting rid of some indexes that we don't actually use, and that ended up saving a lot of disk space, which is really, really nice. We made some actually, this is a community-contributed one, some improvements to the terminus code that we have, where we actually hoisted some logic to a higher level outside of a tight loop, which actually drops the serialization time for an example catalog we had with 10,000 resources from about 80 seconds down to about 6 seconds, which again is still more than a couple hundred milliseconds, but it's Ruby, so you got to take what you can get. We added a lot of features in terms of resilience. Nobody likes, one of the downsides, it's not all roses, the downsides of running on a JVM is, basic things that you would take for granted in other languages, like interop with SSL certificates and things like that, are done in Java's own brain-dead kind of way, where you have to load up certificates into a key store or a trust store. If any of you have used Jenkins or any of those other things, like, you've got to do that kind of stuff. And this was by far the most, I mean, you could talk to Ken Barber, who's been handling, he actually wrote the fixes for this. Which was, he worked with Chris Price, and it's amazing work. But we actually now automatically we'll dynamically create an in-memory key store and trust store for you, and all you have to supply us is the path to your certificate files. So you never have to worry about that ever again. This is the largest source of problems, like on RSC, people complaining to us about they couldn't get stuff running. HTTPS is now much more configurable. In particular, you can configure the set of cipher suites and SSL protocols that you actually care about. And you can do that in order to match whatever your company's security policy needs are. Like if you only want this particular version of TLS, or you don't want to use a certain cipher, you only want to use like Diffie-Hellman encoding or something like that. This is important for installations that have like security standards that they need to meet, like government installations, military stuff, I think. Use my software for good, not evil. Even though evil will win, because good is dumb. A lot of things are more automatic now. We automatically recover from message queue corruption, which was never really serious, but it would prevent you from starting up unless you had to manually clear out a directory. And I was like, well, you know what? If I was a user and there was an error and the remediation was to RM this directory, why don't I just automatically do that when I detect the error on startup? So you don't have to worry about that anymore. Anything that goes into the dead letter office is now automatically compressed. We can now automatically purge information from the database about nodes that are no longer active. We can now automatically recycle connections to a database in case you're running your database connections through like a load balancer, which you want to like round robin new connections. So it leaves persistent connections alone, but you want to send a new one to a different part of a database cluster. That's really useful. That was contributed by Chuck Schweitzer from State Farm. We now have backup and restore, which is really, really nice. It's integrated into the daemon. You don't have to download anything extra, and you can actually restore to a PuppetDB instance while it's running. The restore actually uses that asynchronous write pipeline, and what it does is under the hood, it just does HTTP puts to that /commands endpoint, which is nice because we kind of eat our own. By building the system in that way, we can have more elaborate features that leverage that stuff. There are some interesting query changes. The biggest one is that there's now a version 2 API that you guys may be familiar with if you've been using it. Some changes there are that you no longer need to ask for only active nodes. Fact queries are very, very fast. And you can do full queries. In V1, all you could do is you could say, give me all the facts for this node. Or for this CACT, give me just the list of nodes that it's on, which worked for the Puppet Inventory Service API, but not really for much else. Now you can do like full fact inspection. Find me all the IP addresses that start with 10 dot, that kind of stuff. Node metadata is much richer, and it's exploration friendly. All those URLs I had in the slides earlier where I want to find my user account, and it's like /resources/user/my username, that didn't exist in V1, and that now exists in V2. Which means that for the vast majority of cases, you probably never need to write one of those wacky queries. You can probably just use the standard APIs to do that. I'm not going to have time to demo it, unfortunately, but if you go on to docs.puppetlabs.com, we actually have a query guide that Nick Lewis wrote that walks you through construction of these queries and what you can do. A personal pet peeve of mine was, this is also a community contribution. We used to require that you would have to give an explicit accept header of application JSON anytime you wanted to do any query for anything, which really sucks in the command line. Now we accept wildcards, so you can just do this, and it's less typing. This will give you all the nodes. We now have SubQuery support. You can now correlate data from resource queries with fact queries with node queries. This is the example where I want the IP address, which is a fact query, of all my nodes running the Apache service. That combines information queried about resources with facts. That's something you couldn't do before. A big one is we now have report storage. We've had that it's currently under /experimental, but that'll probably be moved out of experimental relatively soon. We come with a report processing plugin. You guys can start using this now. We store report level metadata. We can do queries on events that span reports. And all this stuff is the basis for the Event Inspector demo that you saw. But you guys can use that for your own purposes if you want. One of the things that just landed in master the other day, I apologize because I actually broke all our acceptance tests when I merged when this merged, but I fixed it. Is streaming queries. Streaming queries, you can basically stream results to clients on the fly as they come in from the database. So what that means is you guys basically get massively lower latency for the first response. So in a nutshell, if I say I just want to get literally every single resource I have, what it's going to do is it's going to open up a cursor to the database and just start siphoning the data to you as soon as it possibly can. And then smiley face. I will show this really quickly. OK, so I have a version 1 of PuppetDB running on port 9080, and I want to get all of my packages. How's it going, everybody? Doing OK? You look beautiful. There once was a man from Nantucket. Oh, all right, there we go. Sorry, I can't finish that limerick. So yeah, it took a while before I could actually get all this information. However, if I do that exact same query against the new version, bam, there you go. So it shows up instantly. In fact, how big is this? 6 megs, 9 megs, 11 megs, 14 megs. OK, so you could wait for all of this data to actually come in, or you could just get the first result as fast as you possibly can. How can you possibly do this, Deepak? Like, don't you need something fancy like space-age Node.js technology in order to do all this asynchronous stuff? It's like, no, it turns out if you have a runtime that has actual threads, you can do something in the background while you're talking to someone else at the same time. Threads, it's state of the art for 1985. Stuff that's coming up. This is the last stuff I got. Last year, I said that there were 3 things that we were going to be working on. We were going to be working on historical catalog storage, we were going to be working on report storage, and we were going to be working on something else. I don't remember. But I'm pretty sure we got 2 out of 3, so victory? I think that's passing. Coming up next is I want to start developing tools that allow for replication. This is a really common request that we have from people. I think the first MVP, the foray into this, that I think is the simplest thing that will likely work, is basically having an out-of-band tool that will actually do diff and mirroring. The reason why this works with PuppetDB and may not work with other tools is because effectively PuppetDB is kind of like Git. It's basically an object store. Only the objects that it's storing are catalogs, facts, and reports, and every single one of those has a stable hash that we compute. Because we need that hash in order to figure out how to deduplicate things. Because if we get 2 things with the same hash, we don't store it again. So because we have those hashes, I can say things like, list all the hashes here, list all the hashes on the slave, diff them, do a set difference, and then copy over all the things that are missing. And I could do that. Prototypes that we have on a laptop, you can handle basically volatility for, I think I was trying it with maybe 2,000 or 3,000 nodes worth of data, and having this just run in the background constantly, and it kept up just fine. The nice thing about it is the master actually does all the deduplication effort and all that CPU. So the diff it already knows, it's pre-computed what's missing. So it's actually less work to send it over that way. By developing a tool like this, we can actually combine diff and mirroring in more interesting ways because the concept is very simple. It's like an rsync, right? And you could use rsync to basically do effectively a master-master kind of replication scenario. Take everything from here, send it over there. Don't delete stuff that's missing, though. And then do the same the other way around. And then there you go. You end up with data that's a unification. That's the union of all the data that you have available. And of course, later on, if we really need to, we can optimize this by putting in, instead of an asynchronous diff and mirroring setup that runs out of cron, or it's a persistent daemon or whatever that wakes up and runs when it needs to, because we have those embedded MQs, we can actually just hook them up directly over TCP protected with SSL, something like TLS protocol. And that way, we reduce the latency to basically nothing. Last thing I want to say is that we're working on more flexible routing that we want to do. We've had a lot of requests, especially from really absurdly huge installations, they have database clusters, and they want to do read-write splits. So they want Puppet to be able to get catalogs, facts, and reports from one PuppetDB daemon, to store them, but they want to do reads from a completely different one, maybe like a hot standby or something like that. So it turns out that's not hard to do, and we'll be working on it. And the last thing that people actually want is they want soft failure mode. So basically, if for whatever reason PuppetDB is not available and you can't write to it, rather than catastrophically failing the compilation, instead we can just emit a warning if the user wants. The user can set this up so that we just emit a warning, and then Puppet will just continue doing its business. And the downside is you end up with a gap in your data, but when Puppet runs again 30 minutes later, it'll get populated. But I mean, it's up to the user. I mean, availability is something every user has different needs around, and I think this is something we need to give some better control over. So anyway, this stuff is documented here. It's packaged, or if you use PE, you don't have to worry about it because it's already taken care of for you. You can install all of it using the Puppet Labs PuppetDB module, which is just a couple of lines, and it takes care of everything for you. It is open source. I encourage contributions. This is me. All right. Started a little late, but I know there's a party to go to, but if anyone has any questions, I'm happy to take them now or after I'm mildly hammered. We had one. Yes, sir.
Yeah, so I had a question about the Postgres stuff. So you're talking about replication, you're talking about read-write splits.
Yep.
And why not just push that down to the Postgres layer? Like throw PG pool on there.
Yep. So the question is, why do we need to design our own replication when instead we could do it at the database level? There's a couple of reasons. Straight up, people right now are doing it at the database level, and it works totally fine using off-the-shelf stuff, PG pool or streaming replication in Postgres 9. However, there are a couple of issues with that. I think number one, at the database level, it's pretty low level, right? So it's going to be replicating at a block level. Like any rows that have changed, it's going to be sending those row deltas over the wire to someone else. However, PuppetDB at the application layer has more intelligence about what's going on. Like, it doesn't necessarily have to say replicate every single block. What it can instead say is, OK, here's a catalog that you're missing. Like, store it the way you normally would. And if you actually can dedupe things, you can go ahead and dedupe them and actually result in less I/O. So basically, in a nutshell, we can take advantage of some of the assumptions and semantics that PuppetDB, the application, has that Postgres doesn't have because it's just the database. So we can basically be smarter. And I think it's simpler to do. For example, setting up multi-master replication in Postgres is actually extremely difficult because there's a lot of transaction issues you have to think about. I don't know why MySQL did it, because I think multi-master replication in a relational database is a colossally fucking stupid idea. Yeah, it's not really multi-master ultimately, right? I mean, it's kind of anybody's guess if you have a conflict. But in PuppetDB, because we know that here's the secret sauce. In PuppetDB, we don't update any of the data in place. We always insert new stuff and then clean up the old crap later. So because we don't do that, we don't have to worry about conflicts. If two things have the same hash, it's fine. We don't need to store it again. Whereas at a database layer, all you're talking about is rows, and it doesn't have that higher level intelligence. But that is an excellent question. Yes, sir.
Hi, you had an example where you were querying both facts and resources, and then based on the query of one, you could get some of the other, or even a little bit of both. That's not very well documented on the web docs right now, and I wonder if I could bug you to add more examples, especially not just documentation as here are the principles, go figure out how to put it together, but rather straight up examples.
Oh,
or
yeah.
even maybe I'll just come pick your brain later and write them for you.
Yeah.
Or something.
So the question was basically,
because I've been wanting to do that all month when I'm like, oh my God, this is exactly what I need, and I can't figure out how to put it together.
So the question, or the comment, was basically about the relative paucity of documentation on doing these subqueries between facts and resources. Yeah, we don't have many examples of that. I would absolutely welcome more. Actually, all of our documentation is stored in our Git repo for PuppetDB itself, so you can actually just write examples and then submit a pull request, and we will totally merge them. Yeah, I don't know. I'll buy you a beer or send you a T-shirt or something like that. I'll staple a $5 bill to the inside of the T-shirt. I don't know. Grease the wheels a little bit. We have VMware money now. I'm going to make it rain. Anyone else? We good? Oh, yes.
Has anyone used PuppetDB to store things other than catalogs?
question was, has anyone used PuppetDB to store things other than catalogs? Not that I am aware of. People have put in catalog-looking things that haven't necessarily come from Puppet itself. People have definitely put in facts that don't come from Puppet itself. A really good example is we had some prototypes floating around, and this will probably land in a very soon upcoming version of Razor. Razor is our bare metal provisioning tool. It actually boots a machine over Pixie with like a microkernel. And the microkernel actually has factor on it, and then it runs factor to figure out info about the machine, and then it sends it over the wire. And it's trivial to actually modify that to send it to PuppetDB, which means if you're using Puppet Enterprise or anything else that hits the inventory service API, you can actually start doing inventory service queries for systems that don't even have an operating system on them yet, or don't even have Puppet on them yet. And again, that's the power of actually having documented, versioned, like proper APIs that aren't like a freaking SQL query. That's the best example that I can think of. I haven't heard of anyone. The downside of that CQRS approach is that the database schema is hyper-optimized for the exact kinds of queries that Puppet users want to do, which makes it, the trade-off there is that it's not generic. You know, it's specific and we get speed out of it, whereas if it was generic, it would be slower. So that's kind of it's a mixed bag, but it's the truth. Anyone else? Go home, download my stuff. Let me know. Thanks.